Okay, the mobile cloud concept. Before we looked into the possibility to connect other devices. Once we connect to the other devices, the question is which other resources will we find on the other side, right? And here's a nice picture of a mobile phone, right? And with different things that we could share. So for example, multiple phones in a room could share the speakers, the microphone, the camera, the display, the sensor, and the keyboard, something that we categorize as user interfaces. If you, at this point in time, you don't know how you can share these resources, wait a minute, I will give you some examples for that. Of course, you can also share the cellular link, right? Even the short range. Often the short range is just a means to share the other resources in an effective collaborative manner, but you can also share these devices. We call this the communication interfaces. And of course, you could even share virtually your battery, your CPU, your storage, or apps, right? Where you have apps running on the devices and they do something in a cooperative way. Also, this we will explain later. If you read some of our earlier books, the app symbol was not here, but I think it's a nice extension to our previous work. So if you have all the resources, how can you really do that? And in order to show that this kind of resource sharing is not something new, I found a paper later on. There was a guy, Bill Joy, he said, a cell phone has a microphone, it has a numeric keypad, it has a display, it has a transmitter and a receiver. That is what it is. It has a battery with a certain lifetime. It has a processor and some memory. If it's a European model, it has a stored value card. It is a collection of things. It is some collection. That fact that is all one bundle, well, this is pretty artificial. So here you see even this guy explains that there are different resources that are by certain randomness or artificialness, they are in one bundle, but they could be even bundled in different ways. And this is interesting because this kind of bundle is the mobile phone, but we can even think about different bundles of virtual bundles. So it's a very nice quote. And this guy, he also invented the Jini concept in Java. And there are some of the things went into that. There are other people that also thought about this. If you think about the project Ara, this was the idea of building a mobile phone. You have here a display maybe and something like a core, and on this core you can plug in things that you would like to see. You need Bluetooth, then you will plug in like on a Lego block and you click it into your phone. You can even rearrange the phone. Here the resources are real physical devices and you plug them in. But you could also think about these physical things in a different way, that you can think about this as virtual resources on the phone. Oops. Now, there's another one, the Möbius phone, that has, it's a little bit more fancy, but even here you can click in different things like more memory, more wireless devices, whatever you need, you can plug it into your phone as you need it. In the early days, you could change the battery and the storage. Nowadays, the battery is even sealed into the phone very often, if not all the times. The only thing you can sometimes add is a little bit of memory. The question is, if you then combine different phones, right, with different capabilities, why are you doing it? And we have two different things. One is the capability extension, and the other one is capability augmentation. Augmentation is clear. Assume you would like to bundle all the cellular links that you have. Then we have all the same, or more or less the same way of cellular access. Combining them over the short range is a capability augmentation. But if I, for example, from the mobile phone would like to use the camera of a camera or the video cam here for video and for a still picture, then I would use these kind of resources, and this is more a capability extension, right? And the devices like the camera or the video camera could use the cellular link of the phone to send out the media they just produced. So two different scenarios on how we can augment our capabilities by combining resources in a very good way. Now here you see the capability extension. You have here a mobile phone, and here something like an iPad where you can write on this. Here you see on the right side we don't have cellular links, but we at least have in common the short range. And because of this bridge that we are building here, we can now extend our capabilities on the user interface, the communication interface, or the other things that you see down here: battery, computing power, or the storage. And why should you do that? So what you see here on the right side is a monolithical point. You need a very big cellular air interface that will eat up a lot of battery in order to give a service that is characterized by the display and the audio output device and the keyboard, right? And if you then draw the circle down here, that would be the comparison in cost. If you compare it then with a cooperative device, where you need only a little bit of the cellular, but and therefore a little of the energy and a little bit of the short range, with others on the other side, with the same given interfaces for the service, then you will see the cost should be a little bit different. There's a little bit of gain here. At the moment I claim there's a gain, later you will even see that, right? But just as a picture where you could expect the gain. I also find this nice picture where two devices really helping each other by giving out the different parts that they have in common and move them around in order to get the best service for one or the other. Now going through some examples, right? One of them is sharing a microphone, right? If you share a microphone on a mobile phone, why should you do that? If you take a single microphone and you go to a concert and you would record something, you will see that the audio quality is very bad, right? And what we did together with Nokia at Roskilde, we recorded with multiple of these devices a concert. So if you go there with 100 mobile devices, record the concert, each of them will have a very bad audio recording, because sometimes people are shouting into it, that it was so loud that the microphone was not very good in recording it. But if you combine these recordings of 100 microphones, there's something called blind source separation, where you can increase this kind of quality. So here it's very easy. Everybody records, send it up to the cloud. You run a process over the 100 audio files, and you get something back that has a way better quality. So this is something where you use the microphone. You can even use the loudspeakers. This is more loudspeakers, still microphone on top of here, where you can use social stereo or 3D social sound, where you place the mobile phones around you and play one song with multiple devices. This we have already demonstrated. It's very surprising how loud these kind of loudspeakers become, and it's compared with a very good loudspeaker. Instead of having one big one that you have to carry around, you just play out the song over multiple devices. You have often heard kids in the tram that are using the single loudspeaker, and the quality is very bad. But why not using more of these loudspeakers? As I said, with the microphone, you can cancel out the noise. The example was there before. And here's an example how you could even share displays, right? Imagine you have one phone and you have a picture like this, and you would like to show it to people. It's not that you can see that much, right? But you can even do different things. You can combine your phones when you have your friends. They will plug them together like this, and you see a way bigger screen by that. This is not only an artificial idea. There was something done like this by MIT Media Labs. They just placed random phones, not even of the same type. Here we had the same type. It looked easy. Here you just plug in some phones, you lay them around. It's an app that will place a QR code, and with the next phone you just make one picture about the location of the QR codes, and this phone that knows the location of the phones will also send out parts of the picture to the phones that they should display. So in the end you get something like this, right? You have still some holes here, so you may want to make a better rearrangement of that. Maybe this big one in the middle and the other one outside. But it's an app that you can download now. It's a way of sharing the display. You can even make pictures, right? If you, for example, have pictures of the same motif, you can combine them to make a bigger picture or even better quality picture by overlaying that. So a lot of devices making pictures and then sending it to the cloud, and the cloud would come up with a bigger or better picture and send it back to you. There you don't even need the short range communication. This is just over your cellular link, right? So this kind of idea is not new. So I got this from the Technische Museum in Berlin. 3D picturing was something big already in the 20s, and they had one camera with that, and they want to have 3D pictures. And nowadays, if you think about virtual reality, you can make these kind of pictures with one camera or with multiple cameras shooting at the same time, making really good 3D pictures. And this is for tourism, for example, the Tower of Pisa, right? Getting some people sending up their pictures, and you could take this to make bigger pictures, 3D pictures, or getting out the noise, right? Sometimes there are people running through your picture. You can even get rid of them if you want that. Sometimes you even have people in front of it because you would like to have them. Okay, so the other thing is you could even share the storage, right? So imagine that you have a storage that you normally have on your phone, and if you lose your phone, all your data is lost, right? Therefore, people are doing a backup on a cloud server, but you could even do this for a short time with other devices around you. So in this case, what we did is we just stored some of our data on neighboring devices. Here, 1/3, a little bit more than 1/3, to 4 devices. So in case one of the devices get lost, we still can retrieve the information. This kind of storage, if you going to the lecture of network coding, there's a way how to do distributed coding here in order to make it very efficient and also robust, and to get the data quick back as soon as possible. The other thing is sharing the CPU. Later you will find some example for this. The idea is instead of using your CPU that with a certain clock rate for a certain time to end up your task at a given point, which will use a lot of energy, why not doing it on 2 different devices? And the funny part is, if you divide it between 2 devices, you will not only use half of the energy, you will only use a quarter of this. This has to do with the clocking range. So what you have to do, you only have to make sure that you end at the same time, so you can clock down the CPU on your computing device, and with this you will save a lot of energy. We will see this later how this works. For now, you have to believe that this will work one way or the other. Now, all of these ideas, they have been later patented way later than the idea were presented, but there was a lot of interest from some big companies. For example, Microsoft, right? Microsoft made a patent that included something like video display aggregation, CPU memory aggregation, storage aggregation, battery aggregation, radio antenna aggregation, multiple microphone aggregation, speaker aggregation, camera aggregation, and keypad aggregation. Some pictures of their IPs looked like this. 2 devices, you click them together. The nice thing here is they said there might be an NFC component or a physical contact so that you can see that they are together, and you get better displays. Here, even a larger one with 4 displays, or you can do it one way or the other. And if you look at the novelty, nothing. Between this physical connectivity between devices in this pattern, there was no novelty. Apple did something similar. They said, oh, we can have a cluster head that communicates with devices, and then they connect to the network, and then we have cloud communication up here to let other clouds talk to each other. They had something like this already patented as well. And this was a patent in 2008. This was a patent in 2008. There must be a time where the evil struck back and said this is something they would like to patent, and in the US you can patent anything, whether there is prior work or not. So if you compare these kind of things, some of our prior work was in 2003, where we had exactly the same things, where we had multiplayer networks. At that time, we looked more into gaming, because gaming, you needed something about latency and other services, and then they would go to the wireless overlay cellular communication system, that would go over a billing entity to an IP network to have different service providers helping us to understand what we can do here with the different service that we have in a cooperative way. So there's prior work, and with that we covered you a little bit, right? More of that way before 2006, 2008, where the patent placed. There are the two books really discussing these applications in detail. Okay, with that, I would like to come to the cooperative reliable multicast, where we come back to the initial example and motivation of our lecture.